on the periphery of the disk. The disk is kept on smooth surface. This is O and it is rough. So what is the question? The person of mass m1 walks on periphery of a circular disk of mass m2. Find the angular displacement of disk when person moves or when person moves a quarter length on the disk, quarter length with respect to disk, you write it. Quarter length means you will have an angular displacement of pi by 2 radian with respect to disk. Find the angular displacement of disk when person, okay, I think quarter length will get confused. Different books, different way they're telling displacement of this when person is having quarter will be how much? Pi by 2 here. Radians angular displacement with respect to this. Or when he walks a distance of how much? Pi r by 2. 2 pi r is what? Periphery. Pi r will be half of the circumference. Then pi r by 2. When he walks a distance of pi r by 2 with respect to disk. They may trouble you like this also. Here I give when a person is having pi by 2 radians angular with respect to disk or walks pi r by 2 distance with respect to the disk. I think both are one of the same. The disk is hinged above the axis. It is only free to rotate. The disk is only made to rotate. How to do this problem now? So what is this problem? So to what you should relate? You should try to relate this to what? Person walking on a plank, center of mass. When a person moves from one end to another end, what is the displacement of plank? Same approach is what we are bringing here. There it was linear momentum considered, here angular momentum is considered. So when a person walks here, I think I'll give the plain diagram. Or when a person walks here, friction will act like this, and the friction on the disk will act here. So then about 0.2, what is the net torque? Will be 0, no? F into R. What is this F? The friction acting on the person when he walks. So he will move along the periphery, no? So let me go for one plain diagram. These are the questions which you are supposed to have imagination. No? So there's a person. I'm showing the top view. So he will have angular displacement theta r like this. Then the friction, how friction will act in this direction. Then on the disk, you have to show like this here. This is radius r, no? One problem, I think you have some some around 8 numericals are there, not 1, 2. All that 8 numericals at a stretch. You can manage with this idea. What is this F? There are 2 F's are there. One F is, this F is friction on the disk. What is this F? Friction on the person. It's not a block. I think please do understand. And what is theta? Displacement of the person with respect to the disk here. And now because of this friction, tell me in what direction the disk will rotate. The disk will rotate in anti-clockwise. theta 2, and the angular displacement of person theta with respect to ground. This is a ground, no? It's a smooth. Okay, now what is our question? What is the angular displacement of the disk is asking? So we'll do one thing. Theta r is equal to theta 1 minus theta 2. What is theta r? Theta r, anything clockwise, I'll take it positive. This is positive. I don't know the angular displacement of person, delta T1, I'll write it. And let it be towards right, this one. And that of the disk, what happened will be opposite, no? And substituting with sign. So this will be delta R minus delta theta 2 equal to delta T1. Okay, let's come for that. What is the net torque acting on system about O? Will be 0. So therefore, as the net torque is 0, therefore the angular momentum should be conserved. So, but sir, we don't have angular displacement we have. I think the same formula we can write it. Initial angular momentum about axis passing through. Final angular momentum about axis passing through. Initial angular momentum. The person and the disk are at rest initially. As the person starts walking on the periphery, the disk will start rotating. So therefore, this should be moment of inertia of the person I1 into delta theta 1 by delta t. Because you will have a displacement, angular displacement by time, that nothing but angular velocity it will be, plus this will be I2. Negative sign, I'll put it. Why negative sign? Why negative sign? Because the angular momentum of the disk is anti-clockwise. Or if you are getting confusion, do like this. So this will be 0 equal to I1 delta T1 minus I2 delta T2. So what is the angular displacement of the person that we have just brought it, no? So same thing, no? Just like what all ideas we are, no? We are just utilizing it in systematic way, nothing big. Okay, let's substitute all one. What is moment of inertia of the person? M1 R square. Delta theta 1, theta R minus delta T2. Moment of inertia of the disk. M2 R square by 2. Delta T2. So this will become equal to M1 R square theta R two M1 theta R by 2M1 plus M2. Theta is what? Angular displacement. How much it was? It was pi by 2, no? Substitute that. Return. So what is theta R? Pi by 2. Angular displacement of person with respect to this. The same ideas, nothing big new, nothing new. To be frank, already we have discussed this linear displacement it had. Now what happened? We are discussing for angular displacement. One person. If the two persons are there, okay, now work out for two persons. Okay, I agree this now. So we'll slightly change this problem. Instead of moving slowly on the periphery, let him run with the speed you are. The person, let him run. Then what conditions will come? Okay, I'm going to scroll down. Let's make